All right, notes 2.1 part 3. How many parabolas can go through the same vertex? So we have a parabola here, and how many parabolas can go through that same vertex? Well, we can draw parabolas. We can go down, okay? We can go skinny parabolas. We can go wide parabolas. Point being that through the same vertex, we would have infinite many parabolas. Okay. What features makes each of these parabolas different? Well, those infinite many parabolas, they're going to have different vertical and horizontal shrinks or stretches. So that might be different about them. There could be a reflection, right? So it could be either opening up or down, and yet have the same vertex. And then lastly, their x-intercepts could be different, because as it shrinks or stretches, where it crosses, if it crosses the x-axis, those values would change. What features will these parabolas all have in common? Number one, they will have the same vertex. And number two, they will have the same axis of symmetry. Max and min values. All parabolas have either an absolute max or absolute min, right? There's no relative max or min. It's either max or min. When will parabola have an absolute max or min? Well, again, when a is greater than 0, it is opening up. So it will be an absolute minimum. And then when a is less than 0, it'll be opening down. A is negative. And then we have an absolute maximum. The example here, find the equation for the quadratic function with the vertex of 1, -3 that goes through the point 2, 5. So we're going to write our equation in vertex form. F of x equals a x minus h squared minus k. And we have our vertex, so we'll plug that in. F of x equals a x minus 1 squared minus 3. Now we need to find our a. To do that, we need to plug in values for f of x or y and x, which is this point right here. So we'll plug those points in. 5a, oops. Come on. And this is 2 minus 1 squared minus 3. Let's see, 2 minus 1 is 1. 1 squared is 1. So we have 5 equals a minus 3. So a is going to equal 8. Come back over here, write our equation. F of x equals 8 x minus 1 squared minus 3. Okay, we're going to skip the newspaper problem. We'll do that separately. Let's look at these problems very quickly. Find the standard form equation for the parabola described. All right, it has a vertex of 2, 3, and has a 0 at -1, which means it has an x-intercept at -1. That point then would be 0. Oops, that point then would be -1, 0. All right. F of x equals a x minus 2 plus 3. Now we plug these values in for f of x and x. Oops. Plug these values in. 0 equals a times -1 minus 2 plus 3. This is squared. I keep forgetting to put that's squared. A minus 3 squared plus 3. 0 equals 9a plus 3. Ran out of room. Bring the 3 over, subtract 3 from both sides. So we have negative 3 equals 9a. So a equals negative 3 over 9. A equals negative 1/3. Ran out of room here, but that equation would be f of x equals negative 1/3 x minus 2 plus 3. And we'll do number 2 over here. Slide this over. Same idea. We've got our vertex and we've got a point. F of x equals a x minus h plus k. I'm going to put all of these points in at once. So for f of x, I'm going to put in the 6 equals a. For x, I'm going to put in the negative 4. And then this is a minus h, and h is negative 2, so that's going to be a plus 2 plus 0. So I can just leave that off. Okay, 6 equals a times negative 4 plus 2 is negative 2. Divide both sides by negative 2, and I get negative, oh, wait, 6, oh, I keep, squared, squared, squared. So let's clean this up a little bit. 6 equals negative 2 squared is 4, so that's 4a. So a equals 6 divided by 4. 3/2. Our equation then is f of x equals 3/2 x plus 2 squared. That's it. There's no k because that's 0. All right, last one here is find any two quadratic functions, one that opens upward, one that opens downward. Here are our x-intercepts, our zeros, x-intercept. So we're going to use our intercept form. F of x equals a times x minus p, x minus q. All right, so let's put in those values. This is our p and this is our q. So f of x equals a, x minus 3, x minus 9. F of x equals a, x squared. Let's see, negative 3x minus 9x is negative 12x, and then negative 3 times negative 9 is plus 27. Okay, this, it wants it opening upwards, so that means that a would be positive, and we pick any a. I'm just going to pick 1. I'm going to say a equals 1. So f of x equals x squared minus 12x plus 27. Now for opening downward, we would do all the same thing except for f of x would equal negative a times x squared minus 12x plus 27. So let's say that a equals 1 again. So that would be negative 1 times x squared minus 12x plus 27. We're going to distribute this negative 1 through here. That's going to give us negative x squared plus 12x minus 27. So we just distribute the negative through, and that gives us this equation here. So opening downwards, we have that leading negative x squared, otherwise negative 1x squared. Over here on opening upwards, we have a positive value.